Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to learn basic properties of magnets. First one is magnetic dipole moment. In our first lesson we have studied about electric dipole moment. The magnitude of electric dipole moment is equal to product of magnitude of one of the charges and the distance between them. In this lesson we are going to study about magnetic dipole moment. Consider a bar magnet. Let Qm be the pole strength, L be the distance between geometrical center O and one end of the pole. Then how do you define magnetic dipole moment? Magnetic dipole moment is defined as product of its pole strength and magnetic length. It is denoted by the letter Pm. It is a vector quantity. Pm vector is equal to Qm into 2L. Here Qm be the pole strength, 2L be the magnetic length. So Qm into 2L, or we can write Qm into D vector. This is equal to Pm vector. What is this D vector? D is a vector drawn from south to north pole, and the magnitude of D is equal to 2L. So Pm, magnetic dipole moment Pm is equal to Qm into 2L, or we can write magnitude of dipole moment is equal to 2 into Qm into L. SI unit for magnetic moment is ampere meter square, because SI unit of pole strength Qm is ampere meter. Here we have L, so SI unit is ampere meter square. The direction of magnetic dipole moment is from south to north pole. Next one is magnetic field. It is denoted by the letter B. Magnetic field is the region or space around every magnet within which its influence can be felt by keeping another magnet in that region. Then how do you define magnetic field? Magnetic field is defined as force experienced by the bar magnet of unit pole strength. It is written as B vector is equal to F by Qm. What is this Qm? Qm is nothing but pole strength. Know that SI unit of pole strength is ampere meter. Then what is the unit for magnetic field B vector? It is nothing but Newton by ampere meter, or you can write Newton ampere minus 1 meter minus 1. This is the SI unit. Next one is types of magnets. Magnets are classified into natural magnets and artificial magnets. Iron, cobalt, nickel are examples of natural magnets. Natural magnets are very weak and the shape of the magnets are irregular, but artificial magnets are made by us, so we can get desired shape and strength. Suppose if the magnet is in the rectangular shape or cylindrical shape, it is known as bar magnet. Next one is properties of a magnet. A freely suspended bar magnet will always point north-south direction. You know that magnets attract another magnet or magnetic substance. So the attractive force is maximum at the ends of the magnet. Suppose When you dip the magnet into the iron fillings, they cling to the ends of the magnet. Third one, when the magnet is broken into pieces, each piece behaves like a magnet. Then two poles of the magnet have pole strength equal to one another. Consider a bar magnet. Here the length of the magnet is known as geometrical length. The length between two poles of the magnet is known as magnetic length 2L. From O to QM L, from O to this QM is L. So totally 2L. 2L be the magnetic length. Another important point, magnetic length is less than the geometrical length. So the ratio between magnetic length and geometrical length is 5/6 or 0.833. Next one is magnetic field lines. Magnetic field lines or magnetic lines of force, both are same. Here magnetic field lines are continuous closed curve like this. The direction of magnetic field line is from north to south pole outside the magnet, south to north inside the magnet. The direction of magnetic field at any point on the curve is known by drawing tangent to the magnetic lines of force at that point. Another important point, magnetic field lines never intersect. Then the degree of closeness of the magnetic field lines determines the relative strength of the magnetic field. Suppose the field lines or lines of force are crowded, magnetic field strength is more. The field lines are thin means magnetic field is weak. One interesting information is given in your book about Aurora Borealis and Aurora Australis. People living at higher latitude, which is latitude, suppose this is our earth, means these lines are called as latitude. These lines are called as longitudinal lines. So people living at higher latitude can see dazzling colored natural lights across the night sky. This ethereal display on the sky is known as Aurora Borealis and Aurora Australis. It is otherwise called as polar lights. These lights are seen above the magnetic poles of northern and southern hemisphere. If it is northern hemisphere means it is called as Aurora Borealis. If it is southern hemisphere means it is called as Aurora Australis. We can see Aurora Borealis in Norway or Finland or Greenland. We can see Aurora Australis in New Zealand and Antarctica. Interaction between gaseous particle in the earth atmosphere with the highly charged particle released from sun's atmosphere through solar wind. These particles emit light due to collision. Variation in colors are due to various gas particles that take part in the collision. For example, a pale yellowish or green color aurora is produced when the ionized oxygen takes part in the collision. Suppose blue, purplish or red aurora is produced when ionized nitrogen takes part in the collision. In this class, we discussed about some of the basic properties of the magnet. First one is magnetic dipole moment. It is a vector quantity. It is denoted by the letter PM vector. Magnetic dipole moment is defined as the product of its pole strength and magnetic length. SI unit of magnetic moment is ampere meter square. Next we discussed about magnetic field. Magnetic field is defined as a force experienced by the bar magnet of unit pole strength. It is denoted by the letter B vector. Then we discussed about types of magnet. There are two types, natural magnets and artificial magnets. Natural magnets are very weak and irregular in shape, but artificial magnets are man-made, so we can get desired shape and strength. Then we discussed about properties of the magnet and magnetic field lines. Finally, discussed about Aurora Borealis and Aurora Australis. I hope this video is useful to you. If you like my video, please share and subscribe my video. Thank you.